This video is part of a series. Complete the previous videos in this playlist before you start this video. The complete playlist information, the material and the code file information is given in the video description below.
Until now, we have seen the intuition of transformers. To be honest, I haven't given a complete in-depth of what are transformers. The transformers concept is quite dense. There are so many other hidden details here. But overall, I have given just an intuition so that we can visualize. Very hardly you will be requiring to build a transformer model on your own. Even if you're building, people just tag them as the layers and then they just go about it. We don't really need to go in depth of it, maybe at this level. Maybe at a later level, when you get into expert level, that is when obviously you will have so many other details with you, then you can explore more. But this is for somebody who is using large language model applications, who's using Gen AI, who's not really building large language models, who's just using the pre-built large language models. Then whatever we have discussed, this much understanding is sufficient. Now we will try to build a transformer model, which is from English to Spanish language transformer. So you can solve this problem. In fact, previously, we have run this exercise language 1 to language 2 translation using LSTM already, and it was effective. But now we will try to do it with transformer. There will be two main differences that you will observe. Transformers model building will be quite fast with the same amount of resources. Highly parallel processing is possible. Transformer models will be definitely a little bit more accurate because of the attention mechanism. With the same data, you can achieve higher accuracy. With the same hardware resources, you can build the model much faster. That is what the difference that you will observe. So here is the code walkthrough. Then we will go to the code file. So we will get this spa.txt, which has English to Spanish pairs. You can have a look at the pairs here. In the Spanish pairs, we are starting with start and we are ending with end symbol, so that it will be helpful later on while building the model. While making the predictions, we will take, whenever we take Spanish prediction, we will take the start as input, starting character, and then we would like to end everything. Once the text sees end as the final output, it will stop the prediction. Once the text sees start as the start at the initial value, it will start the prediction. And then some of the train and test data details we are going to see. 15% of the data is reserved for validation, 70% for training, 15% for testing is what we're going to do. We're going to do a little bit of data standardization, removing the punctuation, a little bit of data pre-processing, and then we are going to do the data vectorization, converting it. Before even we do the word to vec, we will convert it into a set of tokens, or we are going to do this data vectorization, which is going to map each and every word into a numerical value so that the processing becomes much faster internally. And then we are going to format the data in such a way that we are going to send a pair or a batch of 64 records each. While training the data, we are going to take a batch of 64 records each, and we are making a fixed size of English sentence with 20 tokens or 20 words, let's say, and Spanish sentence will have also 20 words maximum. So the target shape is also 64 by 64 by 20, as well as encoder input shape is also 64 by 20. 64 sentences or 64 English sentences or English inputs versus 64 Spanish outputs, and each of these English input 20 words max. If we have less than 20 words, we will pad them. If we have more than 20 words, we will trim them. So it is kind of not a large data set, smaller data set, only keeping in mind what are our computational resources. Then we have the hyperparameters. This is the probably the most important aspect, the hyperparameters that we have to set. We have given embedding dimensions 256. So we are converting each word into a vector of 256 length. That is the embedding dimensions, quite high. Latent dimensions are 2048. Latent dimensions here are nothing but the dense layer, number of nodes in the dense layer. So here the number of nodes in the dense layer 2056 or whatever the number that we have taken. This is what the latent dimensions are meaning. Number of nodes in the dense layer are 2048. Again, it depends on how large is your data, what is the complexity of the data. These are the hyperparameter which we have to train. So embedding dimensions 256, you may not need to really change it. Latent dimensions is something that you may have to play around. And number of heads, we are going to do a multi-head attention, parallelly 8 different contexts. So if you take one word, you can actually capture its context in 8 different places. I feel this is sufficient here. If we feel that this is not sufficient, we may have to add more number of such heads. So again, depending on the data, we may have to change these values. As of now, we are going ahead with these parameters. So you have encoder inputs, positional encoding, encoder outputs. You have decoder inputs, and then sequential inputs, masked multi-head attention, decoder, and then finally transformer. Once you compile and then build the model, so we will run it for a couple of epochs, see the output accuracy. So finally, the output looks somewhat like this. We have to create a function for making the prediction also. So that function will take the input as English sentence and it'll try to make a prediction. So these are some of the English sentences. I would not say this is one of the best model in terms of translating from English to Spanish, but this is a decent model. Overall, you will get some good results for sure. Let us go to our code file. The code file is given in the description below this video. You can check it from there. So let's execute this. Input data. So the below package is a custom transformer package stored on my GitHub server. So basically all the code for transformer, the encoder, decoder, this whole of whatever we have discussed here, all of that I have written inside a package. You don't need to really write that. You can use it as it is. And then here is the data file. We will import the data. Maybe we can have a look at some of the data points. That is terrifying. SOS, SOS terrificto. So even I do not know Spanish that much. His anger is understandable. So this is the Spanish version. So this is our input data. Split the data into train, test, validation. So your training data has 83,000 records and then validation data. Like 83,000 records may not be sufficient to totally understand the language, but this is good enough or maybe decent enough. And then do the data pre-processing. I have given a detailed explanation of this code as well. You can have a look at that. So here we got an error. Let us try to see what is that error. So here, while we are trying to print, here we are trying to take a random value between 1 to 100,000. Sometimes it may not be able to pick that up because we have only 83,000 pairs of data, pairs of training data. But we are asking to pick three random values from any of number between 1 to 100,000. Maybe if you make it as 80,000 or 100,000 or 80,000 or 10,000, I'll make that modification in the code. I'll directly give you that 80,000 value. Then we are trying to print what is the final shape of our input data. We cannot give the English sentences as it is. So we have to convert them into sequence of numbers like this. We have to convert them into sequence of numbers. And then finally, we give that as the input. This is the final data that we are going to give it. This all you can consider as pre-processing. I'm not really sure you will be doing this exercise. You will be building a transformer on your own in future. Mostly we will use pre-defined transformers or pre-built transformers. Mostly we take the transformers from Hugging Face and then do this type of tokenization using auto tokenizer. So we don't really build, or you will not have get the need to build your own transformer. Mostly you will take a transformer or you will find the transformer from a Hugging Face. You will be fine tuning it. If at all you are building it, this is the code that you can use. So we are taking batch size as 64, and then we are considering the size of 20 only as the final or the maximum length of the input sequence and the output sequence. Embedding dimensions, word to vec, when you're converting into embeddings, 256 is the embedding dimensions. Latent dimensions, in the dense layer, you want to add 8 or 2048 nodes. And number of heads, you are considering 8. So this is a multi-head attention with 8 heads. Those are the hyperparameters that are in our hand. We are running it for 2 epochs. For you to get a good decent model, you should run it at least for 30 epochs for this model to converge. You are getting some warnings. That is okay. You can ignore those warnings. And these 2 epochs is going to take a little bit of time. So what we will do is we will just wait for 1 or 2 epochs. And then, so there are like 1302 iterations within this 1 epoch. Let us wait for it to run for these 2 epochs. Then we'll proceed further. 20 seconds more to go. Let us wait for it. So we will stop this process. You don't need to execute it. I'll stop this. Now what you can do is you can save the model, you can run it for another epoch also. But I have already run this model for nearly 50 epochs. You can get it from my Google Drive. By executing this, you will get that model downloaded. So here is the downloaded version of that model. Once you execute this code, it's going to download and unzip. It's a quite a big model. Obviously, those many parameters, there are too many parameters. So all of these put together, English to Spanish, 50 epochs, weights.h5 is the file name. And on top of it, we are running one more epoch. So you can say eventually we are running this model for 51 epochs. If you just run this one epoch, it is almost like 51 epochs. Once you run all those 51 epochs, 50 epochs by me and then one epoch by you, we are ready to make the predictions. Once again, to make these predictions, we are writing a function. So we will take the, like for decoder sequence, we will take the input from the encoder and then we convert like for us to make a prediction, we have to write our own function. For us, we have to take the input data from the user and then calculate all those attentions. And then from encoder to decoder attention. Within decoder, we will start the predictions one by one. We will start with the sentence with start and then predict the next word and then calculate attentions, mask the attentions. We have to take care of that masking and then predict the next word masking. Once we hit the word end, then we stop it. That is the next word. Once we hit the word end, that is one of the stopping criteria. Or once we complete the maximum sentence length of 20, that is also can be stopped. So one of those two conditions, if it is met, automatically our overall decoding or the prediction of the target sentence will be completed. So we are going to take a couple of examples from English, and then that will be the input sentence, and then decode sequence, the function that we have written, that will be used for making a prediction. These are some of the random sentences, and these are the Spanish predictions. So that is how transformer works. As I told you, this is just a overall intuition about transformers that I have given you. It's not necessary that one has to totally understand transformers and you will be building transformers day in, day out. That is not really true. You just need to understand the overall architecture. Most probably, either you will be fine tuning or you will be using some of the APIs of the large language models, or you will be using a RAG, or you will be using agents. But in all of them, you will be taking pre-built transformers or the models that were built on top of the transformer architecture. So that is it from my side about transformers. These are the reference links that I found pretty useful. You may also find it very useful. Thank you, everyone. Have a great day.
Congratulations, you have completed the course now. You can check the rest of the courses in our playlist. I'll be adding few more videos in this playlist as well. Once again, congratulations. All the best to you.